Hello everyone, in this video we are going to explore one of the foundational elements of the OSHA Process Safety Management or PSM standards. But it's Process Safety Information or PSI. PSM was created to protect workers and communities from catastrophic releases of toxic, flammable, or explosive chemicals. The standard contains 14 elements, and the process safety management is the second element and arguably one of the most important because it provides the factual basis for all the other elements. Complete and accurate PSI helps engineers design safe systems, guides operators during operations, and ensure that hazard analysis and emergency plan are based on real data. In this video, we'll break down what PSI is, why it matters, and how you can compile it effectively. Before you conduct a process hazard analysis, write operating procedures, or train employees, you need factual information about your process. OSHA's PSM standards requires employers to complete a compilation of written process safety information before performing a process hazard analysis. The purpose is to enable employers and employees to identify and understand the hazards posed by processes involving highly hazardous chemicals. Complete and accurate written information about process chemicals, process technology, and process equipment is essential for an effective PSM program and will be used by hazard analysis teams, trainers, contractors, and emergency planners. Collecting this information is not just a regulatory requirement. It's a practical way to prevent accidents. And without it, engineers can misjudge chemical inventories, design equipment incorrectly, or overlook unsafe operating limits, and leading to incidents such as overpressure, runaway reaction, or explosion. OSHA divides process safety information into three categories: information on the hazards of the chemicals, information on the technology of the process, and information on the equipment in the process. Let's look at each category.
The first category of OSHA PSI is information on the hazards of the highly hazardous chemicals. This category includes properties and hazards of the chemicals involved. OSHA lists the minimum data that must be compiled. Toxicity information. Understand how the chemical affects human health and what exposure symptoms look like. Toxicity values, such as LD50 or LC50, help estimate health risk. Permissible exposure limits, PELS, established by OSHA. Physical data, e.g. molecular weight, boiling point, and vapor pressure. Reactivity and corrosivity data, how the chemical reacts with air, water, or other substances, and whether it corrodes materials. Thermal and chemical stability data, and the hazardous effects of inadvertent mixing of different materials. Mixing incompatible chemicals can cause fires or violent reactions, so this information is critical. OSHA notes that safety data sheets, SDMSs, meeting the Hazard Communication Standard, can be used to satisfy this requirement if they contain the necessary data. However, SDSS might not provide all the information needed, especially detailed process chemistry or runaway reaction data, so additional research may be required. When gathering hazard information, use reliable sources such as manufacturer's data, published references, or peer-reviewed literature. Ensure that toxicity and exposure limit data are current. Regulations or recommended exposure limits can change over time. Document incompatibilities and mixing hazards in plain language so operators and emergency responders understand the risks. The second category is information on the technology of the process. The technology information describes how your process works and what the safe operating limits are. It requires that this information include block flow or process flow diagrams. Simplified block flow diagrams show major equipment and process flow lines with flow rates, temperatures, and pressures. More detailed process flow diagrams include valves, instruments, pressure and temperature data for feed and product lines, and often show materials of construction and control loops. Process chemistry. Identify the chemical reactions taking place, reaction orders, energy changes, side reactions, and catalysts. This helps assess runaway reactions or byproduct formation. Maximum intended inventory. State the maximum quantity of each hazardous chemical that will be present in the process. Safe upper and lower operating limits for temperature, pressure, flow rates, and composition. For example, a reactor may have a safe temperature range of 50 to 100 degrees Celsius and a pressure limit of 10 bar. Document both the normal operating range and the absolute safe limits. Consequences of deviations. Evaluate what happens if the process deviates outside the safe limits, like a rise in temperature can lead to runaway reaction, or a drop in pressure can allow air ingress in a flammable mixture. Describe potential outcomes qualitatively or quantitatively, like risk of explosion. Information on the equipment in the process. The last category addresses the design and capabilities of the physical equipment. This includes materials of construction, engineering drawings, and codes used. According to the model, the equipment information must cover materials of construction for vessels, piping, and equipment. Knowing whether a vessel is stainless steel, carbon steel, or another alloy helps assess compatibility and corrosion risk. Piping and instrumentation diagrams, P and IDS. These diagrams show valves, instruments, and the relationships between equipment and control systems. They are essential for design, maintenance, and hazard analysis. Electrical classification, areas of the process classified for electrical hazard, for example, Class 1, Division 2, and appropriate equipment rated for those areas. Relief system design and design basis. Document relief valves, rupture discs, and their sizing bases. Ventilation system design. Design codes and standards employed such as ASME pressure vessel codes, API piping codes, or NFPA fire codes. The compliance guidelines recommend documenting which codes and standards were used to establish good engineering practice. Material and energy balances for processes built after May 26, 1992. Material and energy balances help verify inventories, heat loads, and equipment sizing. Safety systems, interlocks, detection systems, or suppression systems. Employers must also document that equipment complies with recognized and generally accepted good engineering practices, RAGAGEP. For older equipment designed under outdated codes, the employer must show that it is still designed, maintained, and operated safely.
Now that you know what information is required, how do you compile it? Here are some practical steps. The first step is gathering chemical hazard data. Collect STSs for all chemicals and verify that they include toxicity, exposure limit, physical properties, stability, and incompatibilities. Supplement STSs with process-specific data such as reaction kinetics, calorimetry study, or literature values for runaway reactions. The next step is develop process flow diagram. Work with process engineers to create block flow and process flow diagrams that shows equipment, flows, temperature, and pressure. Keep diagrams updated when modification occur. Use software tools to maintain consistency in this step. The third step is determine safe operating limits. It's very important in process safety. Establish normal operating range and safe upper and lower limits for key variables such as temperature, pressure, flow rate, and composition. Document the consequences of deviation and incorporate interlocks or alarm to warn operator. The fourth step is document equipment information. Compile P&IDs, mechanical design specification, material of construction, electrical classification drawing, and real-life system analysis. Verify that equipment meets appropriate codes and standards. For older equipment, provide evidence that it is maintained and operated safely. The fifth step is organizing the information. In this step, store PSI in a central accessible system. Many facilities use digital document management system to keep the information up to date. Ensure that employees, contractors, and emergency responders can access the information they need. The next step is keep PSI current. Whenever changes are made to chemicals, equipment, or operating conditions, update the process safety information. Management of change or MOC procedure should require a review of PSI to ensure consistency. Pre-startup safety review or PSSR must confirm that PSI is complete and accurate before introducing hazardous chemicals. Process safety information is more than paperwork. It's the factual foundation of your entire process safety management program. OSHA requires a compilation of written information on the hazards of chemicals, the technology of the processes, and the equipment in the process, and emphasize that this information must be complete, accurate, and readily available. Compiling and maintaining PSI helps you design safer systems, conduct thorough hazard analysis, write effective operating procedures, and train personnel. By investing time and effort into gathering this information and keeping it current, you're not only complying with the law, you're protecting your workers, your facility, and your community from catastrophic process incident. Thank you for watching. If you have any question about process safety information or other PSM elements, feel free to leave them in the comment. Stay safe and see you in the next video.